Okay, let's get started. Sometimes the most interesting connections pop up where you least expect them.
Definitely.
Today, we're sort of digging into one of those, connecting some pretty advanced math concepts to farming, specifically chickens.
Yeah, it's a really neat example, actually. We're looking at a proposal aimed originally at college students for a deep dive focused on estimating protein conversion efficiency.
Right, in broiler chicken,
Exactly. And not just any broilers, but ones raised specifically on farm-grown feed.
which adds that real-world variable, doesn't it? It's not a generic lab setting. How do these chickens turn this specific feed into protein?
Precisely. And the source's main idea, the kind of hook, is using mathematical tools differentiation and integration, calculus basically, to figure this out.
Okay, hold on. Calculus and chicken coops. Not the most obvious pairing.
Huh, no, it isn't. Your first thought is probably just, weigh the feed in, weigh the chicken out, simple subtraction.
Yeah, like basic accounting.
But this approach, it's much more dynamic. It gets inside the process. So yeah, let's explore why this works and why it's interesting, especially if you like seeing different fields kind of smashed together productively.
Okay, so where does differentiation come in? What does that tell us about the chicken?
Well, think about growth over time.
Hmm.
It's not constant, right? Differentiation lets you look at the rate of change at any specific point in time.
Oh, okay.
So how fast is that chicken actually converting protein on, say, day 15 compared to day 40, not just the overall
I
average?
gotcha. It's like looking at your car's speedometer, your speed right now, instead of just calculating your average speed
Yeah.
for the whole trip based on the odometer.
Exactly that analogy. It gives you the instantaneous snapshot of efficiency.
And integration, then. Differentiation is the speed.
Integration is how you use that speed information, even if it's changing all the time, to figure out the total distance traveled.
Right.
So for the chicken, you're accumulating all those little instantaneous rates of protein gain over a period of week, the whole growth cycle, to find the total protein accumulated.
Okay, that makes sense. So differentiation for the right now efficiency, integration for the total gain over time based on those changing efficiencies.
Precisely. And this is where it gets really useful for someone managing the farm. That simple input-output average hides a lot.
How so?
Well, with the calculus approach, you might see that maybe efficiency peaks early on, then dips, maybe recovers a bit later. It's not just a straight line.
Or maybe this particular farm-grown feed blend performs differently than a standard commercial one at certain growth stages,
Exactly. You can model that. You could potentially see, peak efficiency with this feed happens around week 4, or it drops off sharply after week 6.
which gives you actual information to act on.
Right. Maybe you adjust the feed mix then, or introduce a supplement at a specific time, or even figure out the most economically efficient time to, process the birds. It moves beyond just measuring to actually understanding and potentially optimizing the process.
So it turns calculus from this abstract thing into a...
Yeah, using that high-level map to get really concrete, actionable insights right there on the farm. It's about understanding the dynamics.
Okay, so let's recap quickly. We've basically explored how differentiation and integration, tools often stuck in math class, can give us a really detailed picture of protein conversion in these specific broilers on their specific feed.
Mm-hmm. It really shows how versatile these mathematical frameworks are. They're lenses, really, for looking at complex systems, biological, agricultural, economic, whatever.
And the real aha moment isn't just that you can apply math, but what it reveals that dynamic, moment-by-moment process, not just a final average.
Exactly. It shifts the perspective.
And for you listening, it really highlights, I think, the value in connecting ideas across different fields. The calculus you learn might just be the perfect tool to understand something seemingly unrelated, like farming efficiency.
It just only makes you think, doesn't it? If calculus can help fine-tune chicken feeding strategies,
Hmm.
what else?
Yeah, what other everyday systems, maybe managing city traffic flow, or even how you water your garden, could be better understood or even optimized if we looked at them through an unexpected mathematical lens?
Something to chew on.